Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, rational numbers topic we are going to continue. So our today's concept is order properties of rational numbers. Order properties of rational numbers. So here regarding rational numbers we have some properties children. Property 1, property 2, property 3. Three properties are there. So for each rational number x, one and only one of the following is true. Means if you have a rational number x, for rational number x, only one condition is possible at a time. If you have a rational number x, so what condition it should follow according to property 1? It may be greater than 0, or it may be equal to 0, or it may be less than 0. So out of these three conditions, only one and only one condition will be applicable for given rational number, one rational number. So one rational number, one condition only applicable. So this is property 1. In order property, this is property 1. Suppose not 1. If we have two rational numbers x and y, two rational numbers x and y. So two rational numbers x and y. So what condition may exist? Then also only one and only one condition is possible. Either first one is greater than second one, or first one is equal to second one, or first one is less than second one. Out of these three conditions, only one and only one condition is applicable if there are two rational numbers. If there are two rational numbers, that is property 2. Suppose if there are three rational numbers, according to property 3, if there are three rational numbers x comma y comma z, x comma y comma z, such that x is greater than y and y is greater than z, so then compulsorily x will be greater than z. So indirectly we are comparing x and y, and we are comparing y and z. If these two conditions exist, so then compulsorily this condition will also exist. So as x is greater than y is greater than z, compulsorily this x also will be greater than z. So this condition is applicable for these two existing conditions. Okay, this is property 3. So these three properties are considered as order properties of rational number children. First property, when there is one rational number. Second property, when there are two rational numbers. Third property, when there are three rational numbers. What conditions to be followed? Okay, so these are the order properties of rational numbers. So next, absolute value of a rational number. Absolute value of a rational number. So in integers we have learnt already. The absolute value of 9 is 9. The absolute value of minus 23 is also 23. Absolute value means it's always positive. Whether the given integer may be positive or negative, but the absolute value is always positive. So absolute means in the between two parallel lines, the given integer to be written, these two parallel lines can be considered as modulus. M-O-D-U-L-U-S, modulus. So we have to write the given integer in between the modulus. If we take modulus of any number, it will always be positive, whether it may be positive or negative. Modulus or absolute value always positive. In the case of integers, we have already learned this. So similarly, in the case of rational numbers also, absolute value of rational number is always a positive rational number with no regard to its sign. Positive rational number 5/7 equals to 5 by 7. Minus 11 by 13 equals to 11 by 13. 65 by minus 24. We have to separately take modulus for two of them separately. Then we can write their value. The negative sign may be in the numerator, may be in the denominator, but no need to bother, no need to consider that. Always the absolute value will be positive, like integers. Okay, children? This is about absolute value. Next. So we have a mathematical operation, addition of rational numbers. Addition of rational numbers. So how to add rational numbers? So in case 1, we are going to add rational numbers with same denominator. With same denominator. So to add two rational numbers with same denominator, we have to add their numerators and we have to divide the sum by common denominator. By common denominator. Adding numerators and dividing by common denominator. This is case 1. So when we can apply case 1? When the given rational numbers are with same denominator, then only we can apply this. If the rational numbers are p by q and r by q, so then their addition will be, because p by q plus r by q we have to add p plus r. Numerators we will take their sum. Denominator q is common. We will take only one time. This sum is divided by denominator. So this is the value of the addition of given two rational numbers. Given two rational numbers. So if p by q, r by q are any two rational numbers, so then p by q plus r by q. What is their sum, children? P plus r by q. P plus r means sum of numerators by q means common denominator. So this is applicable when the rational numbers are with same denominator. Then also we can follow this method. So according to this method, add these two rational numbers. One is positive, one is negative. Add these two rational numbers. This is negative. In denominator we have negative sign. Okay, first one. 7 by 8 minus 5 by 8. 7 by 8 plus minus 5 by 8. 7 by 8 plus minus 5 by 8. So 7 plus of minus. Whenever we have two signs side by side, we have to make use of this bracket symbol. 7 plus of minus 5 by, what is the common denominator? 8. Plus of minus means minus. 7 minus 5, how much? 2. 2 by 8. 2 1 is 2. 2 4 times 8. So 1 by 4 is the answer. Whereas the second one, 4 by minus 5, 3 by 5. So first 4 by minus 5. Is it in standard form, children? 4 by minus 5. Is it in standard form? No. In standard form, always the denominator to be positive. So rational number, before doing calculations, so compulsorily it should be written with positive denominator. So minus 5, how to make turn into positive denominator? Both numerator denominator multiplied by minus 1. 4 into minus 1, minus 4. Minus 5 into minus 1, minus into minus plus, 5 1 is 5. Minus 4 by 5. So for our, before doing the addition, we have to check whether the given rational numbers are in standard form or not. If not, we have to change it first. Now they are in standard form. Now we can add. Instead of 4 by minus 5, we will take minus 4 by 5 plus 3 by 5 as it is. Numerators add. Numerators minus 4 plus 3 by common denominator 5. Minus 4 plus 3, how much, children? Minus 1 by 5. Okay. So in this way, we can add the rational numbers with same denominator. With same denominator. With same denominator. Next. So add minus 2 by 5 and 3 by 4. minus 2 by 5 and 3 by 4. Here, this is second case. Here, denominators are different. Here the denominator is 5. Here the denominator is 4. Denominators are different. So how to add them? For adding rational numbers with different denominators, first step is we have to make the denominators to convert to common denominator with the help of LCM. With the help of LCM. So 5, 4. LCM how much, children? 20. So 5, 4. LCM is 20. So we have to turn the denominators into 20. We have to express the given rational numbers with common denominator 20. So how to change the denominator to 20, children? Here we have 5. To turn into 20, we have to multiply with 4. But what? Both numerator and denominator to balance the value. Both with 4 by 4 we can multiply. Or numerator with 4, denominator with 4 to be multiplied. Minus 2 4 times, minus 8, 5 4 times 20, minus 8 by 20. This is the first rational number changed. First rational number. 3 by 4. 3 by 4 is there. How to turn to 20? 4 5 times 20 to be multiplied by 5. Both numerator, denominator. 3 5 times 15, 4 5 times 20. So 15 by 20. Now instead of the given rational numbers, we will take the changed, revised rational numbers. Now they are having common denominator 20 20. So sum of numerators minus 8 plus 15 by common denominator 20. Minus 8 plus 15 how much? 7. 7 by 20. 7 by 20. Okay. So in this way we can do it. In this way we can do it. So in this way we can do it. So actually we can also do in another way. We can also do in another way. Suppose if we have a by c plus c by d. Suppose if we have a by b, a by c plus c by d. Sorry children, a by b it is. If the rational numbers are a by b and c by d, a by b and c by d, what we can do? BD, this LCM. In the denominator, we can take b into d BD. Here, while doing a by b, b is already present in denominator. So d is missing. So with d, we have to multiply a into d we can write here. While calculating c by d, already d is present, b is missing. With b, we have to multiply c. So a into d plus b into c by bd. Or AD plus BC by BD. So without taking LCM, we can do directly here. So here minus 2 by 5 is there. So what we will write here? We can write common denominator 5 into 4. In the numerator part, minus 2 into 4 plus 3 into 5. That cross. In crisscross method, we will write the product in the numerator. Both the product of denominators we will write in the denominator. So if we write like this, 2 4 times 8, 5 3 times 15 by 20. Okay, like this also we can do. Next children. Suppose 5 by 8 minus 11 by 12 is there. 5 by 8 minus 11 by 12 is there. So how we can write? So 8, 12, LCM how much? 8, 12, LCM how much? 21, 24, 24. While multiplying with 8, 8 3 times 24, 3 into 5. 5 into 3 we have to mention here. While calculating this minus 11 by 12, 12 2 times 24, 2 into minus 11. We can simplify like this. 5 3 times 15, 2 into minus 11, minus 22. Minus 22 into plus, minus 22. Minus 22 plus 15, minus 7 by 24. Okay, children. So, this 24 denominator to be divided by this denominator, 8. quotient is 3. That quotient 3 is to be multiplied with numerator 1, first numerator 5, and to be written here. Same, while doing this common denominator to be divided with this 12, 2 will be the quotient, which 2 we have to multiply numerator and we have to write here. Or for this shortcut is there. So a by b plus c by d is there. While simplifying, while doing addition, so in the denominator place, LCM of this b and d we have to write. In the numerator part, a into this LCM by this b means quotient we have to write. Quotient of this LCM and b we have to write, because 8 3 times 24, this 3. How we got this 3? 5 into 24 by 3. LCM of 8 and 12 by 3. So here also C into LCM by D. Like this we can write. Next one. So here 7 by minus 18, 5 by minus 12. Both of them, they are not in standard form, because denominator minus 18, denominator minus 12. To be written in standard form first. Multiplied by minus 1 minus 1, multiplied by minus 1 minus 1, minus 7 by 18, minus 5 by 12, minus 9 by 16 also, multiplied by minus 1 minus 1, 9 by 16. So the given 3 rational numbers turned into standard form. Now, denominator 18, denominator 12, denominator 16. 18, 12, 16. We have to take the LCM of 18, 12, 16. So what is the LCM? If you do the LCM is 144. With 18, 144. How many times? 8 times. 8 is the quotient. With that 8 we have to multiply minus 7. Minus 7 into 8. Next with 12, next plus. With 12, 144. How many times? 12 times. 12 is the quotient. With 12 we have to multiply minus 5. Minus 5 into 12. Next with 16. 16, 9 times 144. 9 is the quotient. 9 into 9. So in the numerator we have to write like this. Okay, by 144. Common denominator. So minus 56, minus 60 plus 81 by 144. After simplification, minus 56 minus 60 minus 116. So here how much? 81. Plus minus means minus. So how much? 35. Minus is bigger number. So minus 35 by minus 140. Sorry, plus 144. Okay. In this way, we can add the different rational numbers, either having same denominator or having different denominators. We can add any rational number with the help of LCM. But first they should be turned into standard form. Next they should be turned with the common denominator. Next we can find the answer. Next. Express each of the following rational numbers as the sum of an integer and a rational number. Sum of an integer and a rational number. Okay. So each rational number, whatever rational number is here, it should be expressed as the sum of one integer and one rational number. So 39 by 7 is there. 39 by 7. So here numerator is bigger than denominator. We can divide 7 5 times 35, remainder 4. Means it is having 5 complete parts. Still, after 5 complete parts, still 4 parts are remaining out of 7 parts. So 5 complete parts plus remaining part 4 by 7. 5 4 by 7. Means this quotient plus remainder, quotient after remainder by divisor. Like in the form of this mixed fraction we can write. So 5 4 by 7 means 5 complete parts plus 4 by 7th part. we can write like this. Sum of integer plus rational number. So minus 37 by 5. So 5 times 35. So 5 7 times 35. 2 is remaining 2 by 5. So 7 complete parts, still 2 by 5 part is remaining. But while writing like this, we should not consider minus. Minus first we have to keep outside. We have minus 37 by 5 is there. We have to write it as minus of 37 by 5. Next we have to divide and we have to convert into mixed fraction. So next minus of 7 plus 2 by 5. We have to write like that. Next minus will come inside. Minus of 7 plus minus of 2 by 5. Because we have to write as a sum. So this minus will go to 2 by 5. This plus will be there in the middle. Okay, like that we have to write. So here 61 by minus 8. Denominator we have minus 8. It is not in the standard form. To be changed into standard form by multiplying with minus 1 minus 1. So minus 61 by 8. Minus is there. We have to keep it outside the bracket. So minus of 61 by 8. Now division. 8 7 times 56. 5 remaining. 7 5 by 8. Or 7 plus 5 by 8. Next this minus will come inside. Minus 7 plus of minus 5 by 8. So in this way, we can represent a rational number as a sum of another integer and another rational number. Okay, children? That is about addition. So next, subtraction of rational numbers. So subtraction already we know. Subtraction is an inverse of addition. From our earlier classes regarding this we are learning. So subtraction is inverse of addition. Suppose if xy are two rational numbers, subtracting y from x means x minus y. Indirectly, x minus y indirectly means that x plus of minus y means adding inverse of y to x is called subtraction of y from x. Subtraction of y from x is same as addition of inverse of y. So subtraction is an inverse process of addition. Okay. So when we have two rational numbers, subtraction of two rational numbers also can be written as addition of this. While writing subtraction of addition, instead of second rational number, we have to take additive inverse of negative of or negative of second rational number we have to take. So a plus a by b plus of minus c by d we have to take, and in addition how we have simplified the problems, in the same way in subtraction also we can do. Okay. Next, subtract 7 by 8 from 5 by 12. 7 by 8 from 5 by 12. So here children, they have given 7, we have to subtract 7 by 8 from 5 by 12. So 5 by 12 to be written first, minus 7 by 8 to be written second. But this subtraction, we are changing it as addition, plus. So this 7 by 8 will become additive inverse, minus 7 by 8. What is additive inverse? 7 by 8 minus 7 by 8 equals to 0. So minus 7 by 8 or 7 by 8 plus of minus 7 by 8 equal to 0. So minus 7 by 8 is called additive inverse of plus 7 by 8. Sign will change. During addition, their result is 0. So they are called additive inverses of each other. Additive inverse means just we have to change the sign. So here plus 7 by 8 is there. We will change it to minus 7 by 8. Now 12, 8. What is the LCM? 24. So 12 2 times. Coefficient is 2. Which 2 we have to multiply? 5. 5 into 2. 8 3 times. 3 into minus 7. 5 2 times 10. 7 3 times 21, plus into minus minus, minus 21 by 24. Minus 21 plus 10, minus 11 by 21, 24. That is the answer. Next one, minus 7 by 8, minus 4 by 9. So here, minus we are writing as plus. So, subtraction written as addition. So, for this sign to be changed, means for this whole number, before the bracket, we have to keep minus. So, minus 7 by 8, minus of minus means minus into minus plus 4 by 9. 8, 9, LCM 72. 8, 9 times 72, 9, 7 times. 9, 8 times 72, 8, 4 times. So, minus 63 plus 32, minus 31 by 72. So, next. Third one, 11 by minus 15 they have given. So, not in the standard form. First, we have to change it into standard form. How? By multiplying with minus 1, both numerator and denominator. Let's change it to standard form. Now, subtraction. Now, instead of 11 by minus 15, we have to take minus 11 by 15. Now, subtraction like addition. So, before this, minus symbol will come. Minus into minus, plus. 20, 50 LCM, 60. 23 times 60, 3 into minus 13. 15, 4 times 60, 4 into 11. Simplification, 1 by 12 is the answer. So, in this way, we can subtract any two rational numbers. But the condition is, they should be in standard form. After that, they should be written in the form of addition by taking the help of additive inverse. Then, there should be common denominator. So, then we can simplify as we have done in the addition. Next one. What should be added to this number so as to get this second number? What should be added to the first number so as to get the second number? Means for first number, let it be x. If we add this, for the first number minus 7 by 12, if we add x, then their sum will be second number 9 by 16. So sum of given numbers is 9 by 16. In the given numbers, one number is minus 7 by 12. Required number is sum minus given number. So sum minus given number we can write. So here minus of minus means plus. 16, 12 LCM 48. 16 3 times 3 into 9. 12 4 times 4 into 7. So 9 3 times 27. 7 4 times 28 by 48. 27 plus 28, 55 by 48. So this is the required number. This is the required number. Next one. What number should be subtracted from minus 7 by 8 so as to get 5 by 12? Here they have given subtracted from minus 7 by 8. Means let x be subtracted from minus 7 by 8. So then their difference is 5 by 12. So difference they have given 5 by 12. So one number they have given. One number they have given. So then what will be the required number? What will be the required number? So from the R, you can write like this. So from minus 7 by 8, if we subtract x, we should get the result 5 by 12 difference. Minus x will go this side. Minus 7 by 8, this 5 by 12 will come this side. 5 by 12 equals to required number x. So required number x equal to, so first number minus difference. First number minus difference. Or without writing like addition, direct also we can do. 8 into 12 how much? LCM how much? 24. 8 3 times 24. 3 into 7. Here in the middle we have minus. Let's take minus as it is without changing into addition. 12 2 times 24. 2 into 5. 10. We will write directly without help of addition. Minus 31 by 24. In this way also we can find the answer. So next, simplify. 8 by minus 15, 7 by 20, minus 11 by 35, plus 1 by 5. So all the denominators. One denominator is negative. One denominator is negative. 8 by minus 15. We have to do rough work sideways. We have to do rough work sideways, both by multiplying minus and minus. Minus 8 by 15. Like that it will come. Or if we have minus sign in the denominator, simply we can keep the minus sign in the numerator. That's all. If you both minus sign, because we can have minus in denominator only in two cases. Either upside for numerator positive, denominator negative, or both negative. Only two cases are possible. If denominator is positive, if numerator is positive, denominator is negative, then simply keep the minus sign for the numerator. Or if both are negative, you can strike off minus sign, both will be positive. That's all. So 8 by minus 15 is there. So directly we can keep minus for the numerator, or in the middle, minus 8 by 15 for the whole number. It will become negative rational number. Like that we can keep. So minus 8 by 15, 7 by 20, here minus into minus, plus 11 by 35, plus 1 by 5. So now all are in standard form. LCM of 15, 20, 35, 5. 15, 20, 35, 5. LCM 420. LCM 420. 15, 28 times 420. With 28 we have to multiply 8. 20, 21 times 420. 21 into 7. 35, 12 times 420. 12 into 11. 84 times 420. 84 into 1. Now multiplication. Only one number is having minus. The remaining 3 are positive. If we add 3, it will be 363. Minus number minus 224. If we subtract 139 by 420. In this way, we can simplify. 2 or more rational numbers with more than one operation. Means addition and subtraction together. Okay children, that's all for today. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.